Hello everybody, I hope you're all doing a great job and enjoying the sections. Welcome to Operation Management. I'm Iman Hassanin Taha, Assistant Lecturer at Faculty of Commerce, Business Administration Department, English section. And this section is based on material taken from the textbook under the supervisor of Dr. Ammar Fathi Musa, who is Assistant Professor of Business Administration, College Vice Dean for Environmental Affairs. And today, inshallah, we will take section number 7, chapter 2, productivity and efficiency. And inshallah, we will take an example of productivity on single factor productivity and multi-factor productivity. So let's go. Let's start with the section. First, let's move to on the learning objectives. When you complete this chapter, you should be able to define the productivity, efficiency, and compute single and multi-factor productivity. Also identify the critical variables in enhancing productivity and identify the factor affecting productivity and identifying how to improve productivity as well. Here is the productivity definition. Productivity is the relationship between the output generated from a system and the input that are used to create those output, and mathematically it will be in equation like productivity equal output over the input. So now productivity improvements mean getting more bang for Spank and other, or one, reducing input while keeping output constant, or to increase output while keeping the input constant. And here is just this slide goes over productivity is the ratio of output goods and service divided by the input. So you must make sure you get that there will definitely be a question, and you are going to have knowledge on this for the subordinate scales for the rest of the course. So please pay attention to this slide, and the objective is to improve productivity. Important production is a measure of output only, not a measurement of efficiency. So you may see that again, maybe yes, maybe no. So I'm going to let you digest this formula here before I started speaking to it. So the next 3 slides will present the most common productivity formula used, and this slide illustrates the basic, which is productivity equal unit produced over input used. And this slide show the basic formula, and we are going to get into it, and we are going to illustrate how it's used. It's important to note that the measurement of the productivity can be quite direct, such as case when productivity is measured by labor hour per ton of a specific type of steel. Now also labor hour is common measure of input. Other measures such as capital or dollars invested or material, for example. Also, for example, when we just use of a steel, it would be tons of oil, or it could be an energy or kilowatts of electricity can be used. And this slide provides an example of a single factor productivity measure in this case, the common measure of labor productivity. Therefore, if units produced were 1,000 units and the labor hour used is 25, then $1,000 divided by 250 would equal 4 units produced per hour. So you see how that's work. I want to go over that again. So while you are looking at this slide, here an example of a single factor productivity measure. And as you look at the slide, so you're looking at this slide, if the unit produced were 1,000 units and the labor hour used is 250, then 100,000 divided by 250 would equal 4 units produced per labor hour. Now this slide depicts a multi-factor productivity measure. Notes the multi-factor measure only makes sense if all inputs are expressed in the same unit, which would usually be a monetary unit such as dollar. Now multi-factor productivity is also known as total factor productivity. So you may see it broken down this total factor, but in most cases throughout this course you are going to see a multi-factor. Now multi-factor productivity is calculated by combining input units, and in this case the inputs are labor, material, energy, and masculines. Now this individual's input will compare as the denominator of the equation. And also we have finished here for today, and the second section inshallah will be an example to illustrate more about single factor productivity and multi-factor productivity. So now we will go through an example. So example 1 says that Collins Title Insurance wanted to evaluate its labor and multi-factor productivity with a new computerized title search system. The company has a staff of 4, each working 8 hours per day, for a payroll cost of $640 per day and overhead expenses of $400 per day. Column process and closes on 8 titles each day. The new computerized title system will allow the processing of 14 titles per day. Although the staff, their working hour, and the pay are the same, and the overhead expenses are now $800 per day. So here Collins wanted to evaluate its labor first and multi-factor productivity with a new computerized system. So we will get the old system and the new system. And here Collins uses the basic formula to compute labor productivity and multi-factor approach to compute multi-factor productivity. Okay, so looking at the first computation, the labor productivity was all system being 8 titles per day divided by 32 labor hour computes to 0.25 title per labor hour. Okay, this is the old labor hour, the old labor. So here the old system being 8 title per day divided by 32 labor hour computes to 0.25 title per labor hour. Okay, and this is the old labor productivity formula. Under the new system is computed by dividing 14 titles per day by the 32 labor hour, which is equal 0.4375 titles per labor hour. You got that. So again here colleague uses basic formula to compute labor productivity and multi-factor approach to compute the multi-factor productivity. And looking at the first computation, the labor productivity with the old system being 8 title per day divided by 32 labor hour, and that's compute 0.25 title per labor hour. And in turn, the labor productivity under the new system is computed by dividing 14 title per day by the 32 labor hour, which is equal 0.4375 title per hour. Okay, moving slow with the mathematic formulas, because I know many of you you are management students, maybe a fast management that you weren't expecting a lot of math for data-driven decision, but that's essentially operations management, process improvement, and activities like gap analysis. You may find yourself using a lot of mathematical formula. So you know whereas you may be looking just this course is a required course for your management program, but you aren't expecting math. I'm going to go slow with this, move very slow with the mathematic formula, because I want to make sure you get them right. And here we are computing multi-factor productivity with old system being 8 total per day divided by total of payroll cost and overhead expensive 640 plus 400 is 1040, and that comes out to be in point 0769 on your calculator or your piece of stretched paper, or it's going to be for the purpose of this course we are going to around that up to 0.077 title per dollar. Okay, again we are computing multi-factor productivity with old system, that's 8 title per day divided by the total of payroll cost and overhead expensive, that's 640 plus 400 equal 1040, and this will compute to 0.00769 rounded to 0.0077 title per dollar. And here we have another computation of multi-factor productivity. Again, and here we have another computation of multi-factor productivity, but with the new system, wherein we have 14 title per day divided by the payroll cost of 640 plus 800 in overhead expensive, that's equal 1440, which computes them to which computes to 0.0097 title per dollar. Again, here we have another computation of multi-factor productivity, but with the new system, when we have 14 title per day divided by the payroll cost of 640 plus 800 of and sorry 640 plus 800 and overhead expensive, and this come out to be an 440, and this computes to 0.0097 title per dollar. In summary, looking at the 3 slides, labor productivity has increased from 0.25 to 4,375. The change is computed by subtracting 0.25 from 0.4375, which comes to 0.18. Then you divide it by 0.25, which is equal 0.75, or a 75% increase in labor productivity. So multi-factor productivity has increased from 0.007 to 0.0097. Now this change is computed by subtracting 0.0077 from 0.0097, which is equal 0.002, then dividing by 0.007 for 0.26, or 26 increase in multi-factor productivity. Now what this tell us is that both the labor, which is single factor, and the multi-factor productivity measures show an increase in productivity. However, the multi-factor measure provides a better picture of the increase, because it includes all the costs connected with increase in output. Thank you very much for your listening and your concentrated. Inshallah, we will meet again in another section and another example, um, to another example of single factor productivity and multi-factor productivity, add productivity at all. So see you soon, and hope you all stay safe and good.